Alright, this is the solar cooker presentation by me, Zach King. Alright, so to start out, a little basic information about solar cookers. So basically, solar cookers, beneficial, they're really environmentally friendly. They use a lot less fuel and water than a regular oven would. It's estimated that one solar cooker saves 1 ton of wood each year. So, I mean, you can do the math and that adds up a lot, you know. They use reflective materials to reflect energy that gets sent straight from the sun right into whatever you're trying to cook. In this case, we're boiling water. So basically how that works is it just converts that sunlight energy into thermal energy to cook that. And there are many different types of solar cookers. So here are a couple examples of that. You can see on the left one, that's a pretty advanced, well, they're both pretty advanced solar cookers there. It's just a lot of reflective material being put into this project here. So yeah, there's many different shapes and sizes, but they all work on the same basic premises of the converting energy from the sun into that thermal energy to cook. They're pretty easy to make at home, or you can even buy super industrial solar cookers. I saw them anywhere from $40 to $200, so there's a lot of different options there. So my solar cooker, so to build my solar cooker, I used the information and pictures of other solar cookers that I found online to create something similar to what they made. I used a few simple materials, such as a cup, aluminum foil, tape, and coat hangers. It's a really simple model, but like all solar cookers, they all use the same basic principles. And then what we're going to do is just use the energy of the sun to heat up water in the cup. So this is what my solar cooker looked like. You can see the bottom is that reflective aluminum foil, and then it reflects again up top back down into the cup, and then there's aluminum foil also in the cup. Try to insulate there. Probably should use the black cup, something that would absorb more energy, and because I'm getting a lot of reflected energy in that white cup, so that's definitely made this a little more difficult to work out, but you know. Okay, so the parameters, the date and time I did this project, it was October 27th, which was, I don't know, Saturday, I think, at around 11 a.m. was when I started it. It was a pretty warm day, so that was really good, and sunny, which is important. It was in Greeley, Colorado, and then the mass of my water, so I use density of water times the volume, which is going to give you 0.455 kilograms of water. When I did all that math there, the insolation on that day for the month in Denver, from the appendix, I got the number 1394, and then the area of the cooker is 0.16 square meters. So the experiment trials here. So trial 1, we started out, it was 71 degrees. The water was 58 degrees. At the end of it, it was 73 degrees outside, and then the water was also 73 degrees. That's going to give you heat absorbed at 28500. Okay, and then trial 2, we did 73 degrees outside when I started now, and the 57 degree water just a little bit cooler, and then it was still 73 when this was over, but the temperature of water was a little higher. It was 75 degrees Fahrenheit, and that going to give us a heat absorbed of 34,200. A little rough numbers there just to keep stuff a little more simple. So for trial 1, so the equation Q equals I, which is the insulation times efficiency times the area. And if you manipulate that, get efficiency by itself is going to be Q over I times A, And then, so for the very first trial, I got the number of 127, and then the second trial, I got 153, which is a little bit higher. So for my discussion, basically my second trial was more efficient overall, with a value of 1.2 times more efficient than the first trial was. You could see that because it raised the water by 18 degrees instead of 15 in the same amount of time. I'm guessing the main reason for this, honestly, is because it was a little warmer outside and a little sunnier, so there was more photons going to be hitting the aluminum foil, and that could be absorbed by the water there. I think to make it more efficient, there's a lot of things I could do, to be honest. If I could have found a way to make it so the reflection was a bit more focused on the water that was being heated up, that would definitely help out a little bit. Maybe a little more aluminum foil around it, even, like up on the sides, to keep as much sunlight as possible up in there. Definitely, like I said, the cup should be black. Maybe some black stuff around it would help absorb the heat a little bit. And then also decreasing area would help, as you could see. Go back here. So we see here that this 0.16 is going to be the area. So if you would decrease the area, it would be a little bit better. Alright, and then we got our references here. Just the expanding world of solar box cookers, just the solar cooking wiki, and then solarcookers.org. That's where I got all my information from. Alright, thank you. Have a good day.